soon as you are ready, press start. Okay?
There is some indication, but you can be a little bit, a few minutes late.
Sorry about this, folks. It worked last night.
Yeah, it was working, but previously that was some screen problem. Probably a fix out. Here it's working fine.
No, I'll have to do it not full screen.
Okay. Hide those bars.
Yep.
Right click.
No, can't right click them for some reason.
Just it's very
No, that left. Yeah, it does that though. More.
If it's totally slow, disable 3D acceleration for
I don't think it's enabled. Okay, sorry for the slight delay, folks. My name is Alex, and I have been working on Trac and giving it some full-text search facilities through the Apache Solr project. Just a quick show of hands, who's familiar with Trac? Thought as much. Who's familiar with Solr? Okay, I thought as much. So, just on the off chance there's anybody who on the planet who hasn't seen Trac, it's this. It's an integrated bug tracker and wiki and subversion front end, all written in Python. Often gets deployed when projects need something in a hurry because it's kind of self-contained. Has a bit of a reputation for being hard to configure, I'm told, although I found the opposite. But I won't leave it. The problem we have today is this search box here. This is what we would like it to be like. This is what it is actually like. Basically boils down to a SQL like field 1, like field 2, yada yada yada. So that's great. It lets you search change logs, wiki text, a few other things, but it doesn't let us search any of the attachments to our pages or the contents of the repository itself, which would be very nice to do. So, for that, we need to replace the built-in search. And the first thing we need to do for that is to implement our own search source. The internal architecture of Trac is based on ZOP interfaces. So for those of you familiar with them, we have here a very minimal, this is defined in Trac itself, it's just here for it's just here to show off. iSearch source is an interface which will be implemented by many different classes. It inherits from an interface so that Trac can keep track of it, and it defines two methods. I hesitate to use the word abstract because that's a bit too Java-ish, but basically when we want to provide a search source, we implement those two methods. When we are implementing methods, we need to inherit from this Trac provided class called component, and what that gets us is Trac will instantiate our object for us. It actually acts as a singleton. There is one per Trac process, and the way this works is that when somebody does a search in Trac, Trac goes through all of the things that have implemented iSearch source and calls get search filters. These are basically in the built-in Trac, you can tick a box, I want to search tickets and wiki. Tickets and wiki would be things provided by a search source somewhere in Trac. And then once the user has chosen those and typed in some terms, when they actually click search, this method is called for us, and we basically have the search terms that were entered, just a list of strings, the filters that we had provided and that were chosen by the user, and this is a very noddy implementation just to show the concept. So here is the other side. Again, this is very cut down just to show the concept. This is what is actually happening inside Trac to call all of our components that have provided an iSearch source. Here is the list of components. Again, everything that inherited from component and had implements iSearch source in it will be in this class level attribute. When something in the web interface calls find cute pets to be called, that might be just routed to /cute pets or whatever you want it to. We first of all get all the search filters that are available. We then check if they're cute. If so, they go in a list of chosen filters. The chosen filters are then provided to all of the components that implement the get search result, and we finally return those in the list if get search result returns them. So it's a very simple loop of loops, and this is the way that the built-in Trac search is implemented with SQL queries. The difference in the real world is, or in the real Trac, is that these filters are mapped to what are called realms. So there is a realm for wiki, a realm for ticket, and a realm for changelog. And this is what we would like to extend. So I will now switch to the actual code. Apologies. Oh no. I did have all of this prepared. Fantastic. So, in order to implement FullTextSearch, we are providing our own iSearch source. We have here a We have here a component called FullTextSearch, which implements a large number of interfaces. Most of these are so it can gather the information as it's updated in Trac. The critical one right here is the iSearch source. We then implement a number of configurable search realms. This code around it is just so that you can choose whether to use FullTextSearch or built-in search on a per realm basis. The additional ones we are adding that aren't in the built-in Trac are source and attachment. Doing it this way also allows us to interoperate with things that we don't know about, but which provide their own search source, such as Trac has a plugin for mailing lists, which can also provide search results. So in our actual implementation, we are basically taking the index, which I'll be describing in a second, submitting a search request to Solr, massaging the results slightly so that they fit with the search format that Trac expects, and then sending them back. I won't go too much into this code because time is tight, but please ask me if you want to see anything. Right. I'm about to jump into the internals of Solr itself. Does anybody have Python questions?
Hello. You just showed us how to get data out of the search engine.
Yes.
How do you get the data into the search engine?
That's kind of split over the two sections of this talk. So the way you get data in, go away. Believe it or not, this is better than Linux on its own on a MacBook through a projector.
You can try to log out and re-log in using Unity 2D, maybe.
I think it is Unity 2D. So the way you get data in is that amongst the other interfaces that Trac provides for you as a plugin developer, you can implement interfaces such as attachment change listener or wiki change listener. And if you declare that you implement one of these interfaces and provide these methods in your class, Trac will call them every time a wiki page is changed or created or deleted, and we basically use that to submit the new information to Solr or delete it from the index. Oh, sorry.
So the reason for using Solr is to stay database independent, because I think we could do something like that with a Postgres FullTextSearch maybe, or I don't know if it would be more complex or whatever. I never use it.
If we were to use Postgres' built-in FullTextSearch, that would buy us simplicity in that we're already using Postgres as our back-end database. We don't have to run another process. We don't have to ship data over a socket or over the wire as much. What it doesn't get us, which I'll go into in a second, is some of the features of Solr in that it can parse and index binary documents such as Word documents, PDFs, open document format. Postgres would be able to do the wiki because it's just plain text at the end of the day, as can Solr.
There are attachments and they can be indexed.
With Solr, yes. If we were using the FullTextSearch built into Postgres, then we would have to implement our own binary data extraction. Ultimately, the reason that that Solr was used was the previous version used Postgres, and we had some performance, or the previous teams had some performance troubles. So it's not I haven't done a detailed comparison, but that's the principal thing. You get the document, you get binary files. Okay. So moving on to Solr itself. It is deep in the land of Java. comes from the Apache project, hence it is Apache licensed. It runs as a servlet, so you need a servlet container such as Apache Tomcat or Jetty to host it. All your interaction with Solr as a programmer is over HTTP RESTful APIs. You can actually do a complete indexing with Solr and do a search just with wget. I don't advise it though. All the exchange is XML in our case, although JSON is an option, and you might want to consider that for reasons I'll go into later, and everything is UTF-8. The major way that Solr works is that Solr has a concept of a document. The document is just a lump of key value pairs to be indexed, and you can customize the indexing on a per field basis, but a field could be 10 megabytes of text. So it's not a database, but it does have some database-like properties. And if you're clever, you can actually use it in some ways like a database. When you submit a document, Solr parses it into tokens. Tokens are usually strings. They can also be numbers. Tokens are stored in an index on disk by Solr, and the index is defined by a schema, which I'll show an example of in a second. The critical thing to realize is that this is not something that you use in process. Like PostgreSQL, you have to run it as a server, and it needs managing and monitoring as a server. It is more complex, but the complexity does buy you a few features that an embedded search library might not. So, just a quick warning. We are deep in the land of Java and Apache. There is a lot of XML going on here. So my apologies in advance. I have tried to trim it as much as possible, but these examples, please don't, when the slides are published, please don't use these examples directly. They are very cut down to fit on a slide. So there are two things you need to configure to run Solr. The first is solrconfig.xml. Pretty much you can use the one provided in the Solr example that you can download almost directly. Very little customization. The second one is the schema.xml, which is where you define all the fields that you want to index, how you want to index them, whether they're required, whether you just index them or just store them. You have both choices, and this one will be heavily customized to your application. But again, start with the examples that you can download from the Apache Solr website. Starting from scratch is not advisable. They're almost a complete programming language in themselves. So, wrong button. So, starting with the schema.xml, this is very heavily based on the example schema that Solr ship. We have here our very basic field types. Very little parsing and tokenizing goes on of these fields. They are the closest thing you are going to get to a database field in Solr. And these are the only ones that actually that's pretty much as it appears in the file. This is an arbitrary string, the name. It's just a convenient way to refer to a type that you've defined in multiple fields without having to copy the definition again and again. So if you like, this is the actual type, but we'll refer to it as this when we define our fields. A more useful example for instance, in the case of a wiki page where you've got the actual body of the text and you want to parse it, would be text general. So, again, this is a field type that we are defining, not a field. And in this case, we are going into full-on parse this into tokens, index it, split it, make it as searchable as possible. Starting from the top, we've got our name and our class as before. The interesting parts are that every field type where you define where it is not just something like an int, you must have one tokenizer. So a tokenizer takes a stream of characters, not necessarily bytes, and splits them up into tokens. Tokens could be as simple as just white space delimited, or white space plus a few punctuation characters. There are a large number of tokenizers you can choose. In our case, we are using this email tokenizer factory because it lets us search on the components of URLs and domain names and email addresses. So a search for gmail.com would find anything that contained a Gmail address, or a search for lucene.apache.org would find anything that linked to the Apache Lucene website. I won't go too much into detail in this because time is limited and this is the subject of a book, but basically this is the workhorse of our search facility. So once we have our field types, we can define our fields, and they are relatively simple. Up here we have the fields that are let through unmolested, if you like. They are used in identifiers and filters and sorting. So you generally want to keep those as they came in the input data. You then get to the actual full-text search fields that you want to perform queries on. And in this case, we are indexing the title, the body. There are others as well, but again, only what I could fit on a slide. I'll show you the full examples when we do the demo at the end. And that concludes the schema.xml. The only other file to configure is the Solr config, which is actually what decides whether this particular instance accepts updates, accepts searches, just one or the other. It's roughly equivalent to your root.py in Django, I guess. So here we define a request handler, in this case for our searches. We define a load of defaults. All of these can be overridden at runtime by choosing the correct URL parameters. Going from top to bottom, Solr automatically paginates your results. So if you do a search that matches 1,000 documents, it won't give you 1,000 documents straight away. It'll give you 10 in this case. The def type refers to the default query type that this handler is performing. Use edismax. It's what basically that is short for extended. Sorry, I forget the term. So what it basically means is that there are many search syntaxes you can use. If we weren't using Solr, we were just using plain Apache Lucene. There is a very formal search syntax. You just can't type in some words and hope that it'll search across all fields for them. edismax is basically a nice middle ground between a full search syntax that you can restrict to particular fields, do range queries, that sort of thing, and just type in a couple of keywords and I want to search some sensible defaults. In this case we are using AND queries by default. This is not the Solr default.
Really?
Yes. If there's time at the end, I'll explain exactly the reasoning behind that. And the next one, QF, is short for query fields. So edismax, if you don't in the query specify which fields you want to search, it will use these ones. And the little hat symbol with the number after that you're seeing there is what's called a boost function. So for instance, if we search for John and it matches in the body, that is only half as interesting to us as if it matches a quarter as interesting if it matches in the title. And if we match John in the author field, then that is really interesting and we want to promote that. Basically the search results that Solr returns by default are in order of interest. So it tries to rank them like Google would. The most interesting one first rather than the most recent or alphabetical or something like that. I won't go into the PF right now because it's a rather topic I don't fully understand. So this is our search handler. Basically the name here matches the URL component. So to use this particular handler we would submit a GET request to hostname /Solr/search q equals John, and if we didn't specify anything, all those other defaults would take in place and we would get back a bundle of XML with scores, fields that we had specified elsewhere as being in the default search, and then we would do a second query to the same URL but with a couple of parameters that specify an offset, so you get the next 10 results, and so on and so on and so on. Okay, and going back to the subject of that's how you get data out of Solr, how do you get it in? Again, it's a request handler, but with a different name and a different class implementing it. We've got two update request handlers here. The first one is the default one you use. You construct your own XML packet and you post it. That's it. If you get the right HTTP response back, it means that Solr has indexed those documents, and you either send a second XML packet, which is basically just brackets commit, and it actually writes those, commits them, and they are available to searchers, or you can specify update ?commit equals true, and it will automatically commit. Similar to with databases, your best strategy is to not commit on every document for this performance, not commit after 1,000 documents, but every 10 or 50 documents will get you nice. And the second one here is tying into the real power of Solr in that it can index arbitrary well, not arbitrary files, but a lot of file formats. So if we wish to index this presentation, for instance, we would perform a post to update/extract. It would be handled by this extracting a request handler, and all the text in the document would be transformed into XHTML and mapped to the body field. So that's how we get our attachments and our Subversion repository content into Solr. Oh, right. So that's a whistle-stop tour. I do apologize. It's a lot to fit into a talk this length, but I'd like to finish with showing you some actual files and a quick demo.
Does this already work for Trac? Does this already?
Hello. I suppose this is a Trac plugin that you're going to show us now.
Yes.
Is that available for 0.12?
Yes.
Okay, so we don't have to wait until 0.13 to actually put it in there.
No, so this isn't part of the core of Trac.
Mm-hmm.
This is a plugin that is compatible with 0.12, and I'm just at the end of the talk I'll show you the URLs to download all of this from.
Okay, perfect, thanks.
Okay. So, demos. Please shout if the text is still too small. So what I have here is a Trac environment it's already pre-populated with a repository, some wiki pages, attachments, and so on. And I've cheated a little in that I have a fairly simple script to run Solr just on a non-privileged port with Jetty, run Trac, and afterwards it cleans up after itself. So I'm just going to run that now. And if you're not familiar with Trac already, when to install it, you get two commands. Trac-D, which is a simple web server for running it in developing or just on an intranet. If you want to do it in production, then usual story: mod whiskey with Apache or Nginx with whatever the plugin for Nginx is called. The second command is trac-admin, which is a command line interface for administering your Trac environment. Comes with a load of subcommands. This plugin adds an extra one called FullText, which has some commands of its own. Lets you do index, just update the index in case something's been missed, but don't, if something's already been indexed, don't do it again. If you want to wipe everything and completely re-index to be absolutely sure, then that is re-index, and remove just deletes. List to check to inspect what is in the index, and optimize just passes through to an Apache Solr function, which basically is the equivalent of a Postgres vacuum or a Windows defrag. Just coalesces all of the index and hopefully speeds it up. So I've already indexed these, so index does very little, but if I do a re-index, then that actually deletes the index and starts again, and that is just looping over all of the documents in all of the realms, submitting them to Solr. To give you an idea of the speed, we have a Trac project with a few gigabytes of subversion, a few gigabytes of attachments, a few hundred wiki pages, and that takes about 8 hours to index on a laptop in a virtual machine. No, sorry, 12 hours in the virtual machine on a laptop, about 8 hours on a server with, well, a virtual server. And there we're looping through, oh, there we're looping, that's too quick. So.
Quick question.
Yes?
You said it's taking rather long to index. What is if the wiki site or the attachments or whatever are changing in that time while you are running the index?
So the indexing routine and the updating should catch everything. I apologize to say I wish this had more unit test coverage. I still need to figure out how to get Solr in a test harness so that I can do integration level tests. But it has been running in production for about 6 months now, and we haven't found any documents that it's failed to index. If at any time you're not sure, you can run full text index, and that will loop over all of the documents in all of the realms and check that there is a matching entry in Solr. So if to be absolutely sure, just run full text reindex, and then a few minutes later full text index, or a few seconds later, and you should be double sure. So stop doing that. So now to show you the actual thing. Come on. So Trac itself is running on port 9000. That's just what the script asked it to. And what your users see and what is different to Trac's built-in search is that we have these 2 extra realms. And if we do a search, for instance, there is here, I believe. Okay, that'll do. So if we do a search for IP tables, we should find this attachment. SSH scan on Wikistart. In fact, I've uploaded that several times. But yes, so that takes us back to the document we were seeing before. So that is Trac with FullTextSearch and Solr. Thank you very much for your time. I also promised download URLs. So,
is there any question? Okay.
Can I just want to, a quick
sure.
apology, word of warning. This URL here, I didn't, Sunburnt is a Python library for interfacing to Solr. So you don't have to implement your own XML construction, basically. The plugin, as it's written at the moment, needs a slightly custom version of Sunburnt. So that is just a fork with basically allows Sunburnt to use the extracting request handler, so that it makes it easier to submit binary documents to Solr. I am not the original author of Sunburnt. I'm not trying to claim credit for that, but you do need to use that version of Sunburnt for now. That will get, I do intend to get that upstreamed over the rest of the summer. The second one is the plugin itself. Includes instructions how to add it, how to configure Trac so that the built-in search is disabled and this can replace it. There's also a minor patch to Trac that you'll need to add to your 0.12 install. It only affects one file. Again, I apologize. There wasn't an interface to override the built-in search sources. But I hope to coordinate with the Trac people so that a future release will require no patching. You'll just need to download the plugin and use it. So,
there is the time is finished, but I think that since there is lunch, you can also continue with the questions. So, if anybody wants.
Which alternatives did you look at, and what made you choose Solr?
I'm afraid I can't answer that question because I didn't begin this plugin from the start. It was something I picked up after another member of the team left. What I believe were the reasons, the previous version of our product used Postgres built-in FullTextSearch. There were performance problems. I don't know if that's because it was configured poorly or because it was a limitation of that version of Postgres, but also it didn't do the indexing of binary files. That for us is the killer feature. It basically builds on another Apache product called Tika, and that supports a vast array of file formats that we couldn't hope to do ourselves. And that's almost certainly the reason we went for Solr over other indexing engines.
Just a small remark, in your configuration you valued the title higher than a tag. Is this correct, or is this useful?
That might be something I need to revisit. I'll have a look at that in a second. The title is a bit of a lie in that the Trac doesn't perfectly keep consistent naming between all its, like a wiki page has a name, but a ticket has a summary, and we map the title in the code to all those things that are like the human identifier. That's possibly why it's mapped higher, because it's the actual name of the thing as opposed to a tag attached to it.
I have two questions. One question is whether you fully support Unicode, and the second question is how, because I don't know anything about Solr, whether Solr supports multiple languages. Because I know from other search engines that you have to configure the languages that are being supported, because the search engine uses stop words to not index, say, for example, in English, a or the or these things.
Yes. It's not something I can answer in too much depth because we took the coward's way out and we only support English. So in terms of Unicode support, Solr is UTF-8 all the way through, so there is not a problem with national character sets. There is a minor gotcha in that XML, which is what is the default data format for all communication, and is what is used by Sunburnt, doesn't support all Unicode characters. Yeah, it surprised me as well. So XML 1.0, which is what just about everything out there supports, there are a number of characters at the very low end of ASCII that are in the control character space that are illegal in an XML document. So that is something to watch out for. But the rest of Unicode, yes. In terms of the human language support of Solr, there are tokenizers and filters that we believe can detect the language of a document and annotate it as such and adapt the stop words and the stemming to that language, but it is safe to say that English is by far the best supported. It comes out the box with classes named English stemmer, and there are, in the example schema, special field types for text en general as opposed to just text general, which has better customized stemming support. So you can do other languages, but you need to go deeper into it. It's something that would take longer to get integrated, shall we say. Okay.
Yeah, just a short question. You showed the result page of your search in the demo, and do you intend to use Solr's snippets feature to show extracts of found documents or things like that?
I want to. This was originally implemented as part of my day job, and released with full blessing of the company. I can't promise that I will be working as heavily on it in the future because we have other priorities at the moment, I'm afraid. But I will be sprinting on this and Trac at least on Saturday. So if you'd like to join me then, I can certainly aid you or spend some time on it myself. Obviously, all bug reports, patches, complaints, questions, gratefully received, either to Twitter or to my work email. If anybody wants to go into more depth about how to configure Solr, there are 2 books which are available. I'm halfway through, well, no, I'm halfway through them both. I have them with me here if anybody wants to have a look too, and a bit of advice on how to configure Solr and install it. Right, I think I've kept you long enough. Thank you very much for your time, everybody, and enjoy the rest of the conference.
Thank you.
You can stay here. You
Yes.
can stay here and discuss if you want to discuss with them.
That would be great.
It's not a problem, but we have